Hi everyone, my name is Kara Buck and I will be presenting my individual design project, which is a roller coaster training module. To start with a little bit of background, after 3 years of experience working in the theme park industry as a ride operator, I have realized that the current training methods for brand new associates often push them to operate control panels when they aren't truly ready for it. And this directly compromises safety in a sensitive environment. To mitigate this problem, I designed an intermediate training module that introduces the roller coaster control panel and operations to ride operators in a low-stakes environment. They are able to practice and hone their skills as much as they want, so by the time they get to the real coaster, they feel ready. The module I designed is based off of the defunct Wicked Twister roller coaster. It features an LED light coaster driven by 2 sets of daisy chain shift registers. This allows the LED to travel back and forth between the 2 towers relative to the speed of the actual ride. The model control panel drives the light coaster through the same procedure outlined in the Wicked Twister training manual. The panel features both manual and automatic modes, preparing the operator for whatever errors they may encounter. In addition, there are sensors mounted to the top to simulate a light curtain, one of the safety features of many roller coasters. When those light beams between the sensors are obstructed, a signal is triggered to stop the roller coaster in the brakes. Next, we have the hardware design. Each feature of the control panel is listed in the components table here, and then on the right is the PCB design. The module is driven by a solderable Arduino Mega 2560 microcontroller and is powered by a battery. The PCB is fully contained in the enclosure. Next is the software design. It's from lessons learned in the previous BOPIT project that essentially forced my team to recreate the software implementation from the breadboard to the PCB. I chose to only test each component on the breadboard rather than the full design. In the end, this saved a lot of time in the debugging process as I did not have to debug problems in both the breadboard and final code. I encountered most of my problems with the shift register programming and the interrupts. And then pictured is the function used to drive the back tower LEDs. And then pictured here are the SVG files for the laser cut enclosure design. The light coaster panel on the left was adapted from a desk sign, and the control panel box on the right, the top view only, was derived from an actual control panel design. And then we have some final testing results. So the ride starts up and functions as normal, and the interrupts accurately generate and impede the normal operation. However, I was unable to add the randomly generated errors due to time constraints. However, this was a calculated decision, as they don't really occur that much more than once a day in real life. It also doesn't account for all possible guest situations, like a restraint that won't unlock. And then following this presentation will be a video demonstrating each of the successes listed here. Now we are going to do a brief demonstration of all of the features of the Wicked Twister control panel training module. If you wish to see a more in-depth explanation of the different procedures, please refer to the videos in Canvas. Alright, so we're going to begin with turning the ride on. And we're going to see this nice Welcome to Wicked Twister prompt, and our lights are going to be on. We're waiting for our next prompt, which is to go ahead and check this e-stop here. We're wanting to make sure that it is in the up position, and since it is, we're going to hit this ensure check one time. Our next prompt is going to be to check the motion stop. We're making sure that it is in the right toggle position, meaning that the motion stop is on rather than the left toggle position. Since it is, we're going to go ahead and hit that ensure check button twice, and that'll put us in manual mode. Now that we're in manual mode, we're going to use the home position button to verify manual parking. And once that returns to the station, we're going to go ahead and auto start the ride. So we're going to switch it over to auto mode, wait for that light to jump over, and then once it starts blinking, we're good to do our auto start reset, which is holding this joystick for 1 second in any direction that you wish. And now we're ready to begin operation. So we're going to start with having our guests board, the restraints are going to lock, and then we're going to go ahead and close those gates. And once all of that happens, Wicked Twister is ready for dispatch. We're going to go ahead and dispatch our cycle here, all clear, launching in 3, 2, 1. And we'll observe the light coaster travel up the front tower 3 times and then the back tower twice for a total of 5 swings. And while this is cycling through, this is a good time to talk about our 3 interrupts, which is the brake beam sensor up here, our emergency stop, and our quick stop. We'll test each of those individually after this cycle is over. All right, now that we've returned to the station, we get our next prompt. The restraints are unlocked, and we're going to go ahead and open those gates. Those gates are going to be opened, and then we'll get the next prompts that the guests are boarding, the restraints will lock, and then we'll close the gates and start up the next cycle. All right, and we'll go ahead and launch it here. The first interrupt that we're going to test is going to be our quick stop here. For the sake of time, we'll test it going up the first tower. When we press the quick stop here, instead of continuing like normal, it's going to just stop it back in the station, and we get this error that the quick stop was depressed. To reset a quick stop error, we will auto start the ride. So first we hit this trouble reset to clear our error, and then it's going to prompt us to auto start the ride. Now it tells us to switch over to auto, but as we know, the ride is already in automatic mode, so we're just waiting for this auto start reset. We'll hold the joystick down for 1 second, and we're ready to continue our operation. Now we're going to have the restraints are unlocked. We're going to open the gates, let those guests out that were quick stopped for whatever reason. And our next guests will be boarding, and we'll dispatch the next cycle. All right, gates are closed. Next cycle is dispatched, and this time we're going to test the brake beam sensor, which mimics a light curtain. And when that light curtain is blocked, the ride will stop, similar to a quick stop in the station. So we'll go ahead and we'll stop it on the second swing now. And as you can see, it stopped here, and we have this error, object interference light curtain. And now we're going to reset this in the exact same way as the quick stop. The ride will still remain on, so we're going to hit this trouble reset, and we see this auto start prompt. It's already in auto, so we don't have to worry about that, just waiting for this. And then we'll go ahead and hold the joystick any direction, and we're ready to continue operation again. Start by getting those guests off, and then getting the next ones on. The final interrupt that we're going to test is the emergency stop, which completely cuts power to the ride. All right, we're going to go ahead and open those gates and load the train. As I was saying before, the emergency stop completely cuts power to the ride, and we'll have to turn the ride off and back on, and then go through the full startup procedure again. All right, we'll go ahead and close those gates, and we'll dispatch our next cycle. Now, as said before, these quick stop, emergency stop, or light curtain interference interrupts could occur on any of the swings. It does not have to be a particular one. It is constantly being checked for, so it can occur on any swing at any point during the cycle. So we'll go ahead and we'll hit our emergency stop now before the cycle is over. And we're going to wait for a prompt on this screen here that will state that we need to turn the ride off and back on, and that the ride is in e-stop condition. And so since the ride is in e-stop condition, we're going to need to go ahead and turn this so it releases back up. We don't want it to continue to generate that interrupt. And then we're going to hit the trouble reset button here. It's going to tell us to switch back over into manual mode, and then we're going to continue the starting procedure process as normal. So we'll do the home position to verify the parking. And then once that returns, we will switch the ride over to auto and wait for it to jump over to that auto start. And this is basically the same startup procedure that was occurring before. We're ready to begin operation, and we can continue as normal. And that is every feature at a quick glance of the Wicked Twister training module.